Alright, this is the benchmark number 3 review brochure. Let's fold it up first so it's a brochure, so it's trifold. I'm going to have this facing me, fold it about a third of the way, covering up most of that crease, and then fold this side over like this, crease, and we're ready to go. All right, the main thing on the benchmark number 3 is trig ratios. I'm going to do hypotenuse in red. I'm going to do this side in green and then this side in blue. All right, and just to kind of color code it, you'll notice that the hypotenuse in these 4 trig ratios is the denominator. Sine of f would be that over the hypotenuse, so the green side over red side. The cosine of d would be the same one. Cosine of f would be the same as sine of d. And then you'll see down here that basically the tangents of those two angles are just the flip-flop, the reciprocal. So that is one of the main things on benchmark number 3 is knowing your trig ratios. Another thing you're going to have to know are the different types of angles when parallel lines are intersected or cut by a transversal. Vertical angles are the ones directly across from each other, so angle 1 is congruent to angle 4 because they're vertical. Angle 2 congruent to angle 3 because they're vertical. Angle 5 congruent to angle 8. And angle 6 congruent to angle 7. Those are all the vertical angles. Corresponding angles are going to be on the same side of the transversal. One's going to be on the outside of the parallel lines, one's going to be on the inside. So for example, angle 1 and angle 5 are congruent because they're corresponding. Angle 2 and angle 6 are corresponding. Angle 3 and angle 7 are corresponding, and angle 4 and angle 8 are corresponding. And then alternate interior is referring to alternate, so on both sides of the transversal, interior inside of the parallel line. So angle 3 and angle 6 because they're alternate interior, and angle 4 and angle 5. And then finally, alternate exterior, so alternate different sides of the transversal, exterior on the outside of the parallel lines. So angle 1 and angle 8, angle 2, and angle 7. All of these are congruent. If they're not congruent, then they're supplementary. Supplementary angles add to 180 degrees. They make a straight line. You're going to have to know how to write a translation rule, so make sure you're going from corresponding point to corresponding point. So I'm going to go from A to A prime. A prime is, or the letters that usually have a prime or the apostrophe that's the image. The ones that are just normal are what's called the pre-image, so before, after. So I need to move to the right 4 and then down 2 to get to A prime. So the rule would be I'm going to take my x comma y, so any x, y value, and I'm going to take the x value and add 4, that's 4 to the right, take the y value and subtract 2 down. And that's a translation rule. There are a couple of reflections on the benchmark, mainly over the axes. So if I have point A, which is at -2, 1, and I want to reflect over the x-axis, this one right here, this point is 1 above the x-axis, so its reflection would be 1 below the x-axis. So I'm going to plot that and put it as A prime. It would be -2, -1 would be the coordinates, -2, -1. If I reflect over the y-axis, so this is the y-axis here, I'll change color. Point A is 1, 2 to the left of the y-axis, so I have to go 2 to the right of the y-axis, and I'll call that A, let's call it double prime, and that's at 2, 1. All right, so there are reflections over the axes on the benchmark. It's always good to review the Pythagorean Theorem. I think that shows up on there. a squared plus b squared equals c squared. It doesn't matter what you put in for a and b. It could be this one or this one and flip them around. But c's got to be the hypotenuse. There's two things you can do with the Pythagorean theorem, if not more, but on the benchmark, it's one of these two things. So to find the hypotenuse, you square the sides that are given to you. In this case, you add, and then you take the square root, and I'm abbreviating that, so square root. And that will give you the length of the hypotenuse. This part right here, will also be how we find distance on a grid, which we'll go over in just a moment, but that's essentially what we're doing. To find a leg, we, again, square the sides given to us. We actually subtract in this case, and then we find the square root. Okay, and that will give us the length of the missing leg. The hypotenuse should be the longest side after you're done calculating. One thing on there is point-slope form. So this is the general formula, y minus y1 equals m times, in parentheses, x minus x1. M is the desired slope. X1 is the x value of the point you want to go through, and y1 is the y value of the point you want to go through. So there's going to be two blanks. And with the blanks, we're not going to fill in this or this. So it's going to be y minus or y plus, depending on what you have, equals the slope, and then the x minus or plus, depending on what you have. So, for example, write an equation of a line that has a slope of 1/2. So that's our desired slope. That goes through the point -4. That's our x value, comma 5. That's our y value. So what we're going to do is plug those values into the point slope form. So y minus 5. Okay, that's the. So let me continue to color code here. 1/2 is the desired slope. So that's the m that we want. And then in parentheses, x minus. Now the x value is negative, so x minus -4 is how I'd finish that. And we can simplify that. I meant to put a circle around that. What we can do is, first of all, we can make x minus -4 into x plus 4. Another thing we could do is distribute the half. Y minus 5 is equal to half x plus 2. And if we really wanted to, we could then add 5 to both sides and get it in slope-intercept form, which would be, I'm going to have to put it over here, y equals 1/2 x plus 7. So this would be the slope-intercept form of that equation. So as I referenced over in Pythagorean Theorem, to find distance on a grid, there is a formula. In fact, I think they show it to you on the benchmark, but the way I like to do it is to make a right triangle between these points. Now, what we're trying to do is find this hypotenuse right here. I'll change the color. We're trying to find the length of that side right there. So if we make a right triangle, we can use the Pythagorean Theorem to find the length of that. So this side is 1, 2, 3, 4, 5. This side is 1, 2, 3. Okay, so I'm actually just doing this right down here. I'm going to square those sides. So 3 squared and 5 squared, that's 9 and 25. Add that together to get 34. Now, then I have to take the square root. So the square root of 34 would be my answer. We could get the decimal answer. In some cases, it might actually be in what's called simplest radical form, which this actually might be in simplest radical form. But basically, to do that, just check it on your calculator. What one matches your answer? Square root of 34, or whatever number you get. But again, you use a Pythagorean theorem to find the distance between those points. All right, angles and triangles. A couple of reminders here that the sum of the angles inside a triangle is 180 degrees. Linear pair of angles share a common vertex and make a straight line. They add up to 180 degrees. They kind of look like this. Okay, so these two would add up to 180. So you might be given a problem like this where it gives you a couple of angles, you can fill in the rest. To find this angle, I could take 180 and subtract the angle on the outside. I get that this would have to be 42 degrees. So these two together make 180 degrees. If this is 42, then I can find this one. Since I have this one, I could take 64 and 42, add together and get 106, and then subtract that from 180. And that must mean that this is 74 degrees. You're going to have to know why triangles are similar or not. So these are the three ways we can tell triangles are similar. Side, side, side similarity means that all of the sides are in the same proportion. So by that I mean if I compare 4 to 6 and 8 to 12 and 10 to 15, I'm going to get the same ratio every single time. These ratios are equal, so that makes those similar triangles. Angle-angle similarity is if you know that two angles are the same, then it just by logical reasoning would mean that the third angle would be the same, and when the angles are the same, the shapes are similar. And then finally, side angle side, you're going to be given two sides that are in proportion. So again, if I compare 3 to 6 and 5 to 10, those ratios are equal, and then this angle in between, we call it an included angle, is the same. That would then prove that those triangles are similar. If you can't do one of these three things, then you just say they're not similar. Okay, trig application. So I would suggest if the picture's not given to you, draw a picture. A tree casts a shadow to a point on the ground 20 meters away. So I'm going to draw a tree. All right, there it is. The ground. This makes a 90-degree angle. So 20 meters away, there's a point right here. So let's call it A. Top of the tree down to that point like that. We've got a right triangle. The angle here is 50 degrees. This point, so from the base of the tree to this point here is 20 meters, it tells us. And we want to know the height of the tree. So this would be x. All right, that's what the drawing would look like. Now we need to set up a trig proportion with trig ratio. So I'm trying to find this side. I'm given this angle. I don't really care about the hypotenuse right now, so that tips me off that I'm going to be using tangent. Do I know the degree angle? Yep, it's 50 degrees. Tangent is opposite over adjacent, so I'm going to put x over 20. All right, put this over 1. Cross multiply, x times 1 is x. And so to find this, I would do 20 times tangent of 50. So I'm calculating it right now. 20 times tangent of 50. And it says round to the nearest tenth. So 23.8 meters tall. Okay, so that tree would be 23.8 meters tall. All right, down here, another tree problem. If a tree 28 meters tall casts a shadow 32 meters long, what is the angle of elevation of the sun to the nearest degree? So again, here's another tree. All right, it says it's 28 meters tall. Casts a shadow, so the shadow, now we measure shadows going this way, not this way. So this is the shadow, 32 meters long. All right, so something like this. Okay, so what we're looking for, how many degrees is that angle? So I don't know. All right, yet again, we don't really care about the hypotenuse here, which would be the distance from the top of the tree to this point. What we're interested in is what angle is needed. So we don't care about the hypotenuse. That means we are going to do tangent. Do I know the angle? No. I'm going to call it x. I do know the opposite is 28, and I do know that the adjacent is 32. If I want to find the angle, I'm going to call that x. I'm going to have to use inverse trig. So tan to the negative 1 of 28 over 32. Then it's calculator time. So second tan 28 over 32. And I believe it says to the nearest degree. So I got 41.185. To the nearest degree would be 41 degrees. Draw a picture if it's not given to you. Good luck!